Let hat-u be the specific internal energy of a system moving along with the flow with a velocity vec-v. What is the time rate of change of the total energy of the system per unit mass? A hat-u frac 12 vec-v dot vec-v. B frac d dt hat-u frac 12 vec-v dot vec-v. C frac partial t hat-u frac 12 vec-v dot vec-v. D frac d dt hat-u vec-v dot vec-v. The correct answer is frac d dt hat-u frac 12 vec-v dot vec-v. If P and R the net pressure and net shear stress acting on an infinitesimally small element volume dx dy dz moving along with the flow velocity vec-v, what is the net work done on the system? A ho abla-vec-v abla-dot vec-v. B vec-v-au dot vec-v dx dy dz. C ho abla-vec-v abla-au dot vec-v dx dy dz. D abla-v-au dx dy dz. The correct answer is ho abla-vec-v abla-au dot vec-v dx dy dz. If vec-f is the body force of an infinitesimally small element volume dx dy dz and density moving along with the flow velocity vec-v, which term is the work done by the body force? A vec-f dot vec-v dx dy dz. B hohat-f dot vec-v. C hohat-f dot vec-v dx dy dz. D hohat-f dx dy dz. The correct answer is hohat-f dot vec-v dx dy dz. Frac partial hohat-u partial t abla-hovec-v-hat-u abla-dot-q-s-p abla-vec-v-au abla-vec-v-au. This form of the energy equation is applicable to A. both Newtonian and non-Newtonian fluids. B. Newtonian fluids. C. Non-Newtonian fluids. D. Pseudoplastics. The correct answer is both Newtonian and non-Newtonian fluids. While converting the energy equation from one form to another, which of the following happens? A. Either the left-hand side or the right-hand side of the equation changes. B. Both the left-hand side and the right-hand side of the equation change. C. The right-hand side of the equation changes. D. The left-hand side of the equation changes. The correct answer is both the left-hand side and the right-hand side of the equation change. The energy equation, which is in terms of total energy, can be changed to terms of internal energy using A. Momentum equation. B. Stress-strain relations. C. Equations of state. D. Continuity equation. The correct answer is momentum equation. The energy equation, which is in terms of temperature, can be changed to terms of internal energy using A. Momentum equation. B. Stress-strain relations. C. Equations of state. D. Continuity equation. The correct answer is equations of state.